Non-metals. Now non-metals are brittle and non-lustrous. That is, they can break very easily and they don't have any shine. The example of carbon, sulfur, phosphorus, etc. Let's look at the physical properties of non-metals. First look at the physical state. So usually the physical state of non-metals can be solid, liquid or gases. They exist in all three states. Solids example carbon and sulfur, liquid example bromine, and gases example hydrogen and nitrogen. So these exist in all three states, that is solid, liquid and gases. Luster, that is the second physical property of non-metal. Now non-metal do not have any shine. If you will look at the particular non-metal like carbon, so it is non-lustrous, that is it do not have any shine. Third property is brittleness. Brittleness is that it breaks very easy. It is very brittle, it is very delicate. For example, coal, if you hammer on coal, the coal will break into very small pieces. But there is one exception, that diamond is non-brittle. That is, diamond cannot be broken very easily. In fact, it is the most hardest natural substance which is available on the earth. Except diamond, all the other non-metals can be broken down very easily and they possess the property of brittleness. Third is ductility and malleability. Now, as they are not brittle, they are not hard, so it cannot be changed into thin wire, or when you hammer it, it cannot be changed into thin sheets. So that means they do not possess the property of ductility and malleability. Next physical property is conduction of heat and electricity. So now these are bad conductors of heat and electricity. If you will see, the metals were the good conductors of heat and electricity, but non-metals are the bad conductors of heat and electricity. But there is one exception, that is graphite, which is a very good conductor of electricity. Now some graphite is also used in the pencil that we used in writing. So except graphite, all the non-metals are bad conductors of heat and electricity. Next is densities. Now obviously, as they are not hard, they do have low densities, that is very less densities. Next is boiling and melting point. So they have very low boiling and melting point. They can be melted at a very low temperature. So these were the physical properties of non-metal. That is physical state, they exist in all three states. Lustrous, they do not have any shine. Brittleness, they can be broken down very easily, they are very brittle. They do not possess the property of ductility and malleability, that is they cannot be changed into thin wires or cannot be changed into flat sheets. They do not possess the property of heat and electricity, that is conduction of heat and electricity. They are very bad conductors of heat and electricity. Also, there is one non-metal, that is graphite, which is good conductor of heat and electricity. Densities, they have very less densities, or you can say very low densities, and they also have very low melting and boiling point. Let's look at the chemical properties of non-metal. First is the electronic configuration. Now, electronic configuration of non-metals have 4 or 7 electrons in their last shell. So, in the last shell, there can be 4 till 7 electrons, but not more than 7 electrons. First is nitrogen. The atomic number of nitrogen is 7. So, we can put 2 in the first shell and the remaining 5 electrons in the next shell. Oxygen, which is 8. So we will put 2 in the first shell and remaining 6 electrons in the next shell. Chlorine, which is 17. So we will put 2 in the first shell, then 8 in the second shell and the remaining 7 in the third shell. So you will find that the number ranges between 4 to 7. So for all the non-metals, the valence electrons, that is the last shell, has 4 to 7 electrons. Next chemical property is formation of ions. Now in metals we saw that they were used to lose the electrons, that is whatever was the last shell, that electrons were lost. But in non-metals the electrons are gained. Now chlorine, the electronic configuration of chlorine is 2, 8 and 7. 7 is unstable. So what it will do is, it will gain one electron and it will become stable and becomes an anion, that it produces a negative sign. If it produces positive sign, it becomes a cation, which was happening in the metals. But in non-metals, they gain the electron and become an anion. So now the electronic configuration of chlorine becomes 2, 8 and 8. That means the last shell is complete. Next is oxygen. Oxygen electronic configuration is 2, 6. It requires 2 more electrons. So what it does is it gains 2 more electrons and it becomes an anion, and the electronic configuration is complete, that is 2, 8. Next, for nitrogen, the electronic configuration for nitrogen is 2, 5. Now here 3 electrons are less. For the orbit to complete, or you can say for the shell to complete and the nitrogen to become stable, it needs more 3 electrons. So what it will do, it is gaining 3 electrons, here plus 3 electrons are coming and it is becoming an anion and it becomes stable, that is 2, 8. So here we learned that non-metals, they gain the electrons. Next chemical property of non-metal is reaction with oxygen. That is, when you treat a non-metal with oxygen, then what will happen? So when a non-metal is treated with oxygen, it gives non-metal oxide. And when you treat this non-metal oxide with a base, you will get salt and water. Also, when this non-metal is treated, this non-metal oxide, when we treat it with water, then we'll get an acid. Let's understand this. First, we have a non-metal, that is carbon. We treat it with oxygen. So you will get carbon dioxide. So carbon and oxygen combines to give carbon dioxide. Carbon dioxide, when treated with a base, that is NaOH, sodium hydroxide, it gives sodium carbonate, that is a salt, and water. So when you treat it with base, that is this oxide, when we treat it with base, we get what? We get salt and water. Now, if this oxide that is formed, that is CO2, if we treat it with water, then what will happen? Then acid will be formed. For example, carbon dioxide, when treated with water, it gives H2CO3, that is carbonic acid. When SO2, that is sulfur oxide, when treated with water, it gives sulfurous acid, H2SO3. Then SO3 plus H2O, that is when we treat it with water, we will get what? Sulfuric acid. So that means when we treat oxides with water, we get acid. And when we treat oxides with a base, we get what? Salt and water. Now there are some elements which exist in the nature and they have both the properties. They have properties of metals also and they have properties of non-metals also. And in the periodic table, it lies between the metals and the non-metals. So these are like examples: silicon, germanium, arsenic. These are the elements which have the properties of both, that is metals and non-metals. And any element which has the properties of metals and non-metals, that is they lie between non-metals and metals, and they are called as what? Metalloids.